Hello everyone, this is Vinayak and today I am going to talk about DC coupled BSS solution. As you know, solar PV is the most commonly deployed form of renewable energy which generates DC power, and battery is also a storage device which stores DC power. However, in the most commonly deployed BSS topology, which is the AC coupled topology, the DC power has to be converted to AC power and the AC has to be converted back to DC to charge the battery. But in a DC coupled solution, solar PV panels and batteries are connected to each other on DC side. Hence, the DC generation from solar can be used to charge the batteries directly on the DC side. So what are the benefits of a DC coupled solution over AC coupled solution? It helps you capture higher energy and it gives you better round trip efficiency. It reduces your capex requirement as well as it gives you better flexibility during augmentation. Now let's look at these benefits one by one. First, higher energy capture. During early morning hours or late evening, when the PV voltage is lower than the threshold voltage for a PV inverter, that energy is wasted. However, in a DC coupled solution, that energy is used to charge the batteries. Similarly, during cloud passing, when the voltage drops below the threshold voltage, that energy is used to charge the battery. Secondly, in a typical PV plant, you would overload your PV inverters by 30 to 50%, and that results into DC clipping of anywhere from 0.3% to 2.5%. But in a DC coupled solution, that clipped energy is used to charge the batteries. Secondly, higher round trip efficiency. Since we are avoiding the DC AC and AC DC convergence, especially which also happens through the transformers, in a DC coupled solution, you get 3 to 5% better round trip efficiency compared to a AC coupled solution. Third, reduce capex. In a AC coupled solution, you will have a separate transformer and 33 kV infrastructure for battery inverters in addition to the PV inverters. But in a DC coupled solution, you have only one set of inverters. Hence, your AC infrastructure, the transformers and 33 kV infrastructure is reduced almost in half. In addition to that, as I mentioned earlier, in a AC coupled solution, you will typically overload your inverters 30 to 50%. But in a DC coupled solution, you can overload your inverters by 80% or even 100%. And that also reduces your PV inverter capacity and correspondingly the transformers and 33 kV infrastructure cost. So these are the benefits of a DC coupled solution. Within DC coupled solutions, there are two different topologies. In the first, you connect batteries to PV inverters via DC-DC converters, and we call this PV prime DC coupled solution. In second, you connect PV panels to battery inverters via DC-DC converters, and we call this battery prime DC coupled solution. So what is the difference between the two? As you know, PV inverters are unidirectional and have grid following capability, whereas battery inverters are bidirectional and they have grid forming capability as well. So PV prime DC coupled solutions are good when you want to integrate batteries to large scale open access solar power plants where you do not need grid forming capability. However, for applications such as island microgrids where you need grid forming capability, you can use battery prime DC coupled solution. In addition to that, if you want to integrate batteries to solar wind hybrid power plant, where you would like to charge batteries with wind power as well, that's when you should consider battery prime DC coupled solutions. What are some of the other applications of a DC coupled solution? In addition to integrating batteries with solar or solar wind hybrid power plants, DC coupled solution can be of green hydrogen to form a DC microgrid where batteries and electrolyzers as well as solar PV panels are connected to the same DC bus. In addition to that, you can deploy DC coupled solution even for EV charging application where solar, batteries and a DC-DC chargers are connected to the same DC bus. I hope this video has helped you understand the basics of DC coupled solution. Thank you.